Well, good morning, everybody. Thank you guys so much for joining us. We're really excited about this webinar. We've got some great folks on here who I'll introduce in just a minute. I think it's going to be a good show of all the capabilities that are out there today and what we can do to accelerate your efforts in mapping at night. A few people are already asking a few questions. I do want you to know you should be able to ask questions throughout the webinar. And towards the end, we're going to be throwing those out to all the experts here on the webinar to answer those for you. So stick around for those answers towards the end. And the questions widget there should be open throughout the entire webinar. So some of the things we're going to be covering today are just different in-depth angles on how to tackle this. I know it's been a challenge for some different agencies across the U.S. and that's why we really wanted to come together today. We've got some solid folks here with us today. Drew, if you want to go ahead and introduce yourself.
Yeah, thanks, Justin. I really appreciate you having me today. And good morning, everyone. So my name is Drew. I'm a police officer in Fort Collins, Colorado. We're about an hour north of Denver. Been a police officer there for 20 years this year, and I'm currently assigned to our traffic enforcement unit. I've been a member of our collision reconstruction team for the last 18 years. I'm an accredited reconstructionist. I really got involved in using drones with crash stuff in 2014 that I participated in a National Institute of Justice study looking at, could we use drones to do a lot of the same stuff we were doing with total stations or other methods of measuring. So I've been getting involved in it since then, and I got a certification as a mapping scientist or ASPRS using drones a few years ago. So something I've been working a lot on, and I'm excited to kind of talk with you and share some of the things we've learned.
Cool, thanks, Drew. Right before I introduce OnGood here, I do want to let everybody know this will be recorded. So this will be available for viewing after today. Most of you who are in mapping know who OnGood is, but I'll go ahead and let him introduce himself.
Hey, Justin. Thanks for the kind words there. My name is OnGood Singh, and I'm a business development executive with Pix4D. I do a lot of the work related to public safety and have taught a lot of classes on collision reconstruction within the drone mapping world to different law enforcement agencies around North America. And I tend to manage a lot of our accounts in law enforcement. Then I'm just basically, I don't know, I'm a nerd and I like mapping and I like drones and I like photogrammetry and the science behind all of it. And I like to explain it in simple ways so that folks understand it. And this is definitely a very cool webinar, a very cool discussion topic, because mapping in the dark is kind of counterintuitive, right? When cameras need light to work, and here we're trying to map at night. So it's pretty fascinating. Anyway, thanks for having me on. I really appreciate it.
Of course, glad to have you. And Antonio is with us from Foxfury. I will let him introduce himself as well.
Hi, everybody. My name is Antonio. Work with Foxfury. I've known OnGood for a couple of years now, and I'm excited to work with Drew. Thanks, Justin, for the opportunity. I've been working in forensics with documentation and even just like seeing evidence since 2005. I deal with a lot of public safety and fire users, and this whole drone thing has become very important from speed point of view. And I'm excited to be on this because, like OnGood said, this is a very hot topic in the industry, and just looking forward to presenting this information.
Thanks, Antonio. And my name is Justin Swartz. I work in business development for FLYMOTION. I'll be moderating today. The goal of this webinar from FLYMOTION is just to, of course, bring in these experts and, use their collaborative knowledge to really bring a standard across the board on what to do when mapping in the dark. Of course, like the four of us have been talking about, this is kind of a new frontier. So we're all learning, and these guys are the guys to learn from. So we'll go ahead and get started here. I'll let Drew kind of take over and talk about some of the different challenges that we see when we come to this topic.
Yeah, so what you're seeing here on the slide is this is going to be kind of an overview of the things that as a collective group we discussed. What are the pinch points or the different question areas that people have when it comes to mapping in the dark. So we want to talk about why are we doing this to begin with, and what's kind of the point for mapping it in the dark. Talk a little bit about drone selection and what we have seen as far as drones as well as payloads that work pretty well for mapping day and night, but again, we'll be focusing still a lot about nighttime sort of stuff, and talk about software selection. That Pix4D has a a variety of different packages, and what are the pros and cons of the different ones, and what are you trying to accomplish. Then Antonio can talk some more about some lighting solutions and what he can help bring to our scenes and make this something that's easier for us to do. And then at the very end, we want to talk about best practices. I mean, what are the things that we've learned that will help make you more successful, and what are the questions that you have that maybe we haven't pre-prepared for you that we can maybe help answer?
So this next slide is going to kind of tackle between Drew and OnGood. Why is there a need for this in our agencies?
So I can start off with that one. That you know, from my perspective, and again, I'm coming from the law enforcement realm of it. There's probably some of my friends in the fire industry that are listening as well. But I think we probably have some pretty similar views. That part of it is that, you know, our scenes don't happen always during the daytime. In fact, they usually happen in the worst possible conditions, because that's when things go wrong. So a lot of times we don't have the ability to choose when it's going to be perfect weather or perfect sunlight. So we have to handle our scenes when they occur. There's usually a push for us to reopen scenes or reopen roads or areas that are closed off, and we're trying to investigate something. And we, you know, sometimes for crash, we may wait until daytime because we can see things better and take better pictures, but other times that's not an option for us, and we've got to get roadways and scenes open again. So we've got to do this at night. And the other one that kind of comes to my mind is that there's a good number of times that we want to document the scene as it is. And granted, we're going to be adding lighting to do this at nighttime, but we're still going to capture lighting that was there naturally. If there's enough ambient light, we could actually probably map with just the ambient light. But if it's something that's important to our case about what does the lighting look like at the time, or if we know that it's about to snow tomorrow or something else is going to happen and change our scene and we want to get it as it is, that may drive why we need to do some of this at night. So those are some things that come top of mind for why I would say we do this.
Absolutely. Thanks, Drew. I think Drew really hit on one of the main points that I get a lot is, hey, a lot of bad things happen at night, and we want to be able to document scenes and be able to understand why that collision occurred at night. But also for me and for my role, what I find very helpful is it's all about opening the road faster. I myself personally have been stuck on a trip to the Bay Area in California. There was a collision on the Bay Bridge from Oakland to San Francisco, and I was traveling across that bridge pretty late at night, and there was a collision. They closed down the road. They brought out all these laser scanners, and I was watching from the vehicle that I was sitting in and seeing all of the scene documentation occurring. And the whole time in my head, I was just like, I really wish they were using drones and Pix4D and mapping technology, because we would have mapped the scene, we would have got everything gone. And I sat on that bridge for about 7 hours in the middle of the night. So I saw the sunrise come up over the city. It was beautiful, but I didn't want to be there at all. And for me, that's one of those stories that it's like, hey, we can use drones to open the roads a lot faster, because we can go out there and fly the drone and collect all the imagery and have a scene documented in 15, 20, maybe basically under 30 minutes. And then you can go back to the office and process all that data back at the office. Another question that I get up a lot, that when it comes really down to why should we do this, I think that a lot of the departments I speak with have two trains of thought. It's, yes, we want to be able to do this at night, or there are some folks that are of the mindset, the little more conservative mindset, that we're just getting our drone programs going. We want to do this when we're a little bit more advanced, not right off the bat, because definitely at night there's more complications. It's probably easier to crash the drone, and we want to make sure that our program is successful and intact and nothing goes wrong. So there's definitely two trains of thought that, hey, we got to do the work at night, versus there are a lot of folks out there that don't want to do it right now. But I think with webinars like this and some of the research studies that are happening in the background related to this topic as well from some high profile agencies, we're going to see in the future that this is going to become far more commonplace. And I think that's why we're here today, to talk about something that hopefully in the future will become more commonplace.
Yeah, appreciate it, guys. We're going to go into now some of the use cases for public safety. Drew and OnGood, if you could speak on this.
Yeah, so from law enforcement, that one of the main reasons, one of the main purposes for us to use drones in mapping has always been for crash reconstruction, any kind of collision scene, as well as any kind of an incident scene, whether it's a crime scene or whether it's a crash scene. They're the same thing. It's just involving a different set of weapons or a different environment. But the mapping of a crash scene is no different than the mapping of a crime scene. And so, like for our agency, our traffic unit works very closely with our forensics unit. We use the same tools. We use the same drones, the same total stations, the same laser scanners, and we're constantly learning together how we can apply those. So almost any crash that we get paged out to that's going to be serious injury or fatal, we are probably going to map that scene with a drone unless there's some reason why we can't do that. Then we also are going to use that again for any kind of a homicide or serious assault sort of scene. The thing we're starting to get more into now is that second point, which is that emergency response planning. So I'm lucky enough that I guess my lieutenant for traffic is also in charge of special events. So we have a lot of special events in Fort Collins that are open air venue sort of events. So we're doing a lot of mapping of those for pre-planning. So imagine that you've got a map of the entire downtown area that's maybe going to be shut off and filled with people. And we're going to grid that out at every 100, 150 square feet. We'll grid that out on an overhead map that we've created with the drone that has the most recent data on it. And now when you attend that briefing as maybe the security person, you're going to get handed that map that shows you what all of these different grids are. And if we have a problem somewhere in the venue, we can tell you exactly what grid that's occurring at, so that while I'm watching it from the air with a reconnaissance drone, you can be on the ground going to go see where the problem actually is. And we're not trying to play this game of it's the guy wearing the white shirt and the black hat, that we can get closer to where it's at. So a lot more planning for emergency response stuff. And then as far as entry team data, we use this two different ways. First is planning that we know we could eventually need at some point. So while we've had this whole COVID thing going on, all of our schools have been closed. So it's been very convenient for us to go out and map all of our schools, where we can highlight all of the entry points and all the rally points and all the important places of each school, that can now get uploaded into our GIS system for the city. And it's a new map layer that we can click on and off on our tablets when we're responding to a scene there, or the SWAT commander can look at that when we're going. The second half of that is an actual occurring tactical event. Unlike, in my opinion of this, and this has been our team's experience in the past several years we've done this, is that drones aren't necessarily super useful when the incident is when the crisis is immediately happening. When we need officers to be on guns and making other people stop doing bad things, we don't necessarily always have time to pull out a drone to do something. However, once we've gone into more of a stalemate, where we've gone barricade and now we're trying to figure out how we're going to attack a problem, that's the perfect opportunity for a drone and for us to do some of this mapping. So we'll do it in those situations, or if we know our SWAT team is going to go hit a house on a search warrant, we'll go do a quick map of that area so that we can show the SWAT team in their briefing what it looks like and what they're about to walk into, instead of a Google map that is several years old. So those are all ways that we're using different kinds of maps in law enforcement. And I think OnGod has probably a little more information on fire stuff. So I'm going to let him speak to some of those use cases.
Sure, thanks, Drew. Yeah, from the fire side, I mean, I did a webinar on with some firefighters about 2 weeks ago now on drones with firefighting, and I've been doing a lot more work. I think in the last few years we've done a lot more work with law enforcement and drones, but I'm seeing fire really pick up in their adoption rate of drones and mapping technology. A lot of it comes from the wildland space where folks are mapping fire lines out in the middle of the woods, as well as mapping large forest fires. We had a lot of mapping occurring in California during the really big forest fires like the Carr Fire in Santa Rosa. And then we also have a lot of folks that are starting to adopt mapping in the fire side for controlled burns, where the media or their command typically asks them the question of, hey, how many acres did you burn? And so they go out there and they fly an area, then they burn it, then they fly it again, and they can get the exact amount of acreage of how much they burned in under an hour. Whereas previously, if they had to physically walk the entirety of the perimeter, it could take a couple hours, and it puts them in a safer position as well. And then also in the fire space, we're seeing a lot of, like Drew, like you just said, in relation to the schools, pre-planning for large areas, pre-planning for understanding escape routes, and also the best ways to attack maybe large suburban locations, where to best put your resources. And then of course, search and rescue too is really big. And here we're talking about mapping in the dark. And I think that one of the applications where we're going to be maybe mapping in the dark is a forest fire potentially going through the night, seeing where that fire line's moving through the night, where that fire is going to give us some light to work with. So that's actually going to be helpful. And then also for search and rescue applications where mapping itself is not always the most vital. What's more vital is just capturing images in the same type of technique you would use for mapping, flying these grid missions where the drone's basically doing like a lawnmower pattern in the air automatically by itself, just to capture imagery so that you can find your target on the ground. But I think for fire, there's a lot of applications. For law enforcement, there's a lot, and it's growing. So it's a very exciting field. So here with drones, if you guys, I can start off here. There's a reason that we have these 3 particular drone models highlighted on the screen. When we're mapping in the dark and we already know that we're dealing with additional challenges, we want to make sure that we're choosing hardware that's going to help us successfully with our jobs. And typically in the center there, we see the Phantom 4 Pro, where you can get a Phantom 4 Pro RTK, which is the version on the screen, which has a much better GPS unit, a mapping grade GPS unit inbuilt to the drone, which is why it's a bit more expensive, or the regular Phantom 4 Pro that doesn't have that, really fancy special RTK GPS that gets a lot tighter accuracy, which was important for mapping. But what's really important about all of the reason that these are the 3 models that we have on the screen is because, one, with the Phantom 4 Pro, it's the best mapping drone that has been made, really, so far in the industry when it comes to a quadcopter that's under $2,000 or $3,000. For under that price point, the camera on that system is the best camera. The reason that it's the best camera for mapping is it's a metric camera, which means it doesn't have a lot of moving parts, which is very important for mapping. We never want to zoom in and zoom out as we're collecting our image sets to put into Pix4D software to produce these maps. And also, the lens on this particular camera has a very high quality. It's a very high clarity, optical clarity we call it, which basically means it's a really expensive piece of glass that doesn't distort light that's coming into it. Now, the reason that the Mavic 2 Pro and the Autel EVO II, which are 2 pretty similar drones, are on this screen as well is because, one, they have 20 megapixel sensors that are going to be better for mapping. These are all 1-inch sensors, which means they have more space to allow light to come into the sensor. There's more actual sensor size, which is important. Sensor choice, choosing a camera that's bigger for nighttime when we know that we don't have a lot of light is very important. But also, the really cool part about both the Mavic 2 Pro and the Autel EVO II is they have little landing lights on the bottom of it. And that landing light in the software, you can go and say, hey, stay on for the entirety of my mapping mission. And it's surprising how much light they give out and how good the results can be added to when you actually have the addition of those lights. And early days of mapping in the dark, we had a lot of folks trying out putting lume cubes or putting little LEDs on the bottom of the landing pads for the Phantom 4 Pro, which is why these are the drones that are up there. Drew, do you have any other comments about like what you use in the field and what you found to be the most successful?
So I completely agree with everything that Angad has said, that our agency is lucky enough to have several different aircraft. That we have all DJI products currently. We're still looking at other manufacturers, but we have everything from a Spark up to a Matrice 210, if not multiple variants of those. And our mapping aircraft by far is our Phantom 4 Pro. It's just the best. It has a great camera. It's super portable. It's easy to use. And it does a great job. It has a global shutter, so it's going to take all of the picture at once. It's not going to be writing each line with a rolling shutter, which tends to process a lot better. We also use a Mavic 2 Pro. We have guys that are on patrol, and they're carrying more of the Mavics because they're smaller, they're easier to use, and they'll do some quick maps, and it's been a great aircraft for doing that both day and night. I will tell you, the bigger aircraft, we don't typically pull out the big ones just because they're a lot of work to bring everything out, and honestly, the payloads aren't necessarily the best for mapping. So even if we're going to pull out our Matrice 210, we actually went on eBay and bought a bunch of the old the X4S cameras that were available once upon a time. because those are the exact same sensor as the one that's on the Phantom 4, and it works better for that. But like Angad said, these are the three that I think all of us would agree are good choices for mapping at night.
Yeah, thanks so much, guys. One thing to mention here too, and I think will be mentioned here in a minute as well, is these are all multi-use tools that we're talking about. So we have a lot of questions rolling in about cost justification, and I think something to note is that these drones aren't just going to be sitting in your truck waiting for an accident reconstruction use case. These are multifaceted tools and can be pulled out from many different scenes and scenarios. So that tends to help with cost justification. It's not just a single use thing. Going into the next slide here, we're going to talk about some of the software that is being used. FLYMOTION only uses Pix4D. They're our end-all be-all solution. We think they're the best on the market, and I'll let Angad talk a little bit more about the different programs that they sell.
Hey, Justin, thanks for that shout out. I really work here at Pix4D, and I really wanted this job when I was finishing up school and finishing up my research because of how cool the algorithms are and really how innovative the company stays. And when it comes to dealing with law enforcement and fire and Office of Emergency Management, et cetera, within the public safety space, that also for me includes the DoD space as well, in the work that I do, it's really about desktop processing, not having to charge departments for utilizing cloud processing, for the costs associated with that, as well as some of the information security concerns where you'd rather process everything on your own computer. Then you don't have to put digital evidence up into the cloud. You don't have to deal with some of the ramifications of that, which sometimes may be overblown in terms of how serious it is. We are going to move to the cloud overall in the future, and I think law enforcement is going to be able to do that too. But a lot of folks just aren't ready for that. And when you're approaching them with totally new technology, I think it's better to approach them also with desktop solutions. So when it comes to this realm of public safety, it's going to be Pix4D Mapper, which is our flagship solution. It's the product that really gave Pix4D its name and made us into one of the central pillars of the drone industry. And Pix4D Mapper is an advanced engineering tool. It was never designed to be specific for law enforcement or fire. It's an engineering tool that was designed for land surveyors and civil engineers, and it's been adopted at a very heavy rate within the public safety sector. It's the tool that Drew uses when he does his collision reconstruction. It's the tool that the National Transportation Safety Board uses to investigate accidents, and as well as most of the state patrols out there, and a lot of the local departments too. And Pix4D Mapper it's an engineering grade tool. It takes in images and it turns all these images into 3D models as well as two-dimensional maps. It takes a long time to process. You need kind of a powerful computer, like a gaming laptop, something in the $2,500, $3,000 range, with 32 gigs of RAM, maybe even 64 gigs of RAM, a gaming specific graphics card. It requires training. We have an online course that's 12 hours that teaches folks how to use the software. We also have tons of free information. You can Google almost any question related to Pix4D and you'll get an answer, because we have 25, 30 YouTube videos plus pre-recorded courses, plus all these support articles. And there's also a lot of folks out there that are training classes on Pix4D Mapper itself. And this is when it comes to collision reconstruction, it's the tool that I want folks to use, because it's that engineering level. You're going to get very pretty maps. You're going to get very high measurement detail, but also it has a higher learning curve and it's a bit more expensive. Now, we also have a public safety specific software called Pix4D React. It's a new software. It's been on the market about 7 months now, and it's becoming very popular. Every day I'm seeing more inquiries about it and more trials being downloaded around the country. But we built this software specific for public safety. It's super easy to use. It doesn't need a powerful computer. It works on the machines that most folks already have. It doesn't need a powerful machine. It's very low cost. And quite frankly, I think that almost anybody that, if you can fly a drone, you can make a map with Pix4D React and learn how the whole software works in probably 20 to 30 minutes. It really is that simple. And so when it comes here for collision reconstruction, we're going to focus on Pix4D Mapper. And a lot of the data sets that are going to be shown in a moment here are from Pix4D Mapper. But I have also made nighttime data sets with Pix4D React. And I think for a lot of the non-fatal applications where maybe you don't need the highest level engineering tool, you go ahead and use Pix4D React. And so here on this slide is kind of a demonstration of, hey, you can put the exact same images into either software that the drone has captured, and it will make a map, and they look very, very, very similar. And yes, the Pix4D React map here took about 1.5 minutes to process on my computer, and then the Pix4D Mapper map on the right-hand side of the screen, which is, of the same scene here, flown by the Michigan State Police, that took about 1.5 hours to process. And now you're going to see why Pix4D React was so much faster and why Pix4D Mapper was a bit slower. And here we have a zoomed-in photo where you can see that the crime scene tape around this scene in the Pix4D Mapper map on the right-hand side of the screen, you can see that crime scene tape comes out perfectly. And you can see that the drain looks exactly like it should. Whereas on the Pix4D React map, there's a little bit of doubling on the drain, and you can see that the crime scene tape, because it's waving in the wind, it has a little bit of an error in the center of it. Now, Pix4D React has been designed for fast mapping in the field, map faster than you can fly. But for collision applications, we're going to focus on Pix4D Mapper, which is where most of the data sets, or pretty much all the data sets that we're going to show you in a moment here, come out of. So I think let's go and talk about mapping in the dark.
Cool. Thank you so much, OnGood. Next, we're going to tackle some of the hardware that we recommend in the field. I'll turn it over to Antonio here. Foxfury for FLYMOTION is one of our greatest allies. They make some of the most durable, multifaceted lights you can get, and we recommend them to anybody that comes to us. So, Antonio.
Awesome. Thank you, everybody. Thanks, Justin, for that. Drew and OnGod are just nailing it with respect to the whole speed and element to it. That is just so critical, and it's the #1 reason that I'm seeing so many departments that really, really, really want to use drones in general more to be able to map. And then we're looking at, with the lighting component, what that can do is it can keep that speed element going even during night scenes. So I have 3 slides. I'll show them to you very briefly, but the first one is just one of our scene lights. So you're going to see some pictures, you'll see some reconstruction work. I just want you to get an idea of what the product looks like. So we're talking about an overhead scene light. Everything is self-contained, and these lights have been used. They're all used all over the world. I should say, above all else, this is on every Navy ship in the Pacific Fleet. Everything that we have is tested, and we build it to assume that you're going to be in the worst case conditions possible, because that I've talked to a lot of fire departments and PDs. You just don't get a second chance, unfortunately. And sometimes every second counts, and lives are just, hanging in the balance here. So you get up to 24 hours of battery life. We're going to talk about location here in a second, but these lights are able to be positioned anywhere you want along the scene. The whole thing will collapse into that tube that you see. It's battery powered, it's rechargeable. It can go, this unit here, up to 8.5 feet high, and it's the best tool that we have, at least at this time, for the ability to reconstruct an actual scene, whether it is a crime scene or whether it's an accident scene at night. And so we've got some other slides here that I'll show you that I think will be of value. What I love about working with everybody in this webinar is, we kind of were talking about the practicality aspect of it, and the drones that were selected are such great multi-purpose tools. If you have the ability to just have a drone that only needs to be used for reconstruction and nothing else, by all means, you can get one of those platforms and maybe even a bigger one. But the 3 drones that you saw in the very beginning are very multifaceted tools. They're going to give you that speed element, and they can work with so much more than just the actual reconstruction side. So the same lights in the same way will be able to be used in several different applications. So in public safety, so many of these smaller departments, and so many of you are in smaller departments, and you have so many hats that you wear. So having a tool that only works for a small fraction of your applications just doesn't necessarily serve your needs. So when we say we're assuming worst case conditions, we're assuming that it's a disaster scene and there's power cut out. We're assuming that that there's something going on in the town or city that you serve, and then you have an opportunity to be able to assist. So many of these, I just did a LinkedIn article on night scenes and their frequency and their prevalence. So just a lot of bad stuff happens at night. So with these pictures that I've got, top left, we have folks that use on the SWAT side the same light. It was called the Nomad 360. They use it on SWAT applications. It's like an interior, or it's a tactical wall of light. Anyone on the inside can't see out, but the SWAT department can see in. We've got obviously a van there. It's just a collision scene, an EMS scene. Top right is a portable field hospital in the Caribbean, especially with COVID going on. All of our lights can be decontaminated, but if you do have a tent or something like that, you do need to illuminate the areas, inside of it and outside of it, not to mention the actual location if it's a field item. The lights and the drones can also be used for DUI checkpoints. Those are kind of a big deal, especially as things start to open back up and it's summertime. Bottom middle will be color bands that can be put over the lights to be able to use as triage zones. And the bottom left picture is essentially a tornado collapse, where if you need to get into and out of a structure, that's a tool for it. So everything we have is cordless. It's all self-contained, and you can put it anywhere you want. And so one thing we get a lot of is just, why, our lights are a premium product. They are a premium price. The same thing can be said for the drones and the software. You want something that's going to work and work no matter what, and you have that reliability. So when we build our products, we call it extremium. We're really talking about us not really understanding where in the world someone's going to be, but we're just assuming that you are just having your toughest call of the year that night. So picture on the left, we actually put kerosene onto the product itself, the Nomad 360. While I don't recommend you do that in any way, shape, or form, the light did go for about 3 to 4 minutes before it shut off. So that was exposed to crazy high temperatures, over 1,000 degrees, and it still worked. And then on the right, we have a picture of it being used in rain. So any water is no problem. You can even submerge these items in an actual body of water if you needed to get the job done. But we've had customers that have used these in temperatures below 20 degrees Fahrenheit, and we've had folks like Las Vegas Metro that have used these in temperatures well over 100 degrees. So that would be the lighting, and I know we'll get to some of these topics as well in the Q&A section.
Hey, thank you so much, Antonio, for that. Next, we're going to look at some of the different orthos that I think actually Drew did some testing with these lights, and I'll let the three of these guys kind of go through the differences here that you're seeing on these orthos.
I wanted everyone to be able to take this in just a little bit. There's a lot going on the screen here, but if you part of what we wanted to do as an agency is we're always trying to figure out the best way to kind of light a scene so that we can see the most stuff. We had heard, I've heard a lot about Foxfury Lighting. I've met Antonio a couple times, and we wanted to try out his lights. And so a couple things that I'll just throw out for him, just as a review from somebody who's gotten to use a set of them now, is that I will say that they are all completely self-contained. They're very well made. I mean, they're a heavy light that you can tell that they're going to hold up to a lot of different elements. They're easy to assemble. They're easy to put back away. They do hold a charge for quite a while. They're pretty easy to charge up and get going. But what I like about them most, and what we have right now on our bus, is just some shop lights, right? We went to Home Depot. It's what we could afford. We bought a $30 set of lights, and we've got this bus that we can plug them into, and we can set them up. And there's scenes that we have to do that because we can't get vehicles where we need light, or we don't have enough lights. And it's a pain in the butt to take a drop cord, bring it all the way out there, and try and get this lighting. So these really are pretty good for that. But what we wanted to do as part of our testing and evaluating of these lights, and these are the Nomad lights that we're going to look at first, is compare them to what we currently have. So what you see on your screen on the left is what we would traditionally do with our lighting. Everything that we have been doing for the past 3 years as a program for doing nighttime scenes. So what you see is on the far left, there's the big box truck. That's our scene response vehicle. It's got command lights, which is the big halogen lights that go on fire trucks. It's got 2 banks of those that we're able to use. And then we also have patrol vehicles that we would use for headlights. We did not pull out any shop lights for this one. We just wanted to use the vehicles. And so this is a mock scene. This isn't. This is one that we set up at our service center. We threw out tents just like we normally would. We put out our ground control, marked everything with chalk like we normally would. Obviously, I purposefully made this a scene where we're going to have shadows. And so we have a truck that tried to make a left turn, gets hit by another vehicle that's the through road vehicle. And then off to the right-hand side, there's actually a body over there in the ditch that we decided to make this a pedestrian, that this guy is making a left turn, has to stop for the pedestrian after they hit him, and then they get hit subsequently after that because they're in the middle of the road. You can see the shadow between the 2 vehicles where they're making more of like a V shape. There is some evidence in there, but it's super hard to see. And the other thing I would note is that just to the right of that, it's kind of hard to tell, but there's a vehicle that has its headlights on, that's trying to use vehicle headlights to light up in between those 2 cars, and it's a miserable failure. It's just not doing what we need it to do. This is what it's going to look like with standard sort of headlights, and those really big fire truck lights, how they're going to end up showing up in the pictures. You can tell the landing area, the little landing strip right behind the crash bus. It's really hard to see our landing pad, and that's because the images are getting blown out by all of the light that's getting put out by those command lights. So then we take the exact same scene, we shut all of our normal lights off, and we put the Nomad lights out. So that's what the middle one is. So we had 4 of the Nomad lights that we put on the different corners, kind of lighting this scene. What you'll notice is that the light from those is really consistent. I mean, it actually does a pretty good job of lighting the entire scene with some consistent lighting instead of having so many shadows. You know, right where the light is, we get a little bit of extra. It can blow out some of the pictures just a little bit, but honestly, it actually worked pretty well for us. The areas where we don't have the big truck lights on, we can see our landing pad much easier now. We can see in between the cars, and we're not even adding an extra light to that. It's just the light that's coming from the Nomad going into there. So it processed really well. And this is one, actually, I'll just say at nighttime, that we fly with a decent amount of overlap. In the overlap that we flew with this one, there was a line of pictures that went straight down the middle of this road. And for some reason, the camera on our Phantom was getting blurred images. So we had about 10 images going on the middle of that were all completely blurred. But we were able to remove those pictures and process it into Pix4D, and there's still enough overlap with all the other pictures that it turns out much clearer, and it's a good representation of the scene. And then last, what we wanted to try, and Tony was nice enough to send us a set of Rugos. So they're like these little LED lights that strap onto the landing gear of the Phantom. And I've done a little bit of testing with this with Lume cubes, but we decided to try the Rugo. We shut every single light off, and we just flew with the lights that were on the drone itself and let it light up each picture as it was taking it. So that's what the one on the far right looks like. It actually does a pretty decent job. I mean, where there's a lot of things going on in the road, where there's all the tar snakes and everything else, the camera on the drone was able to focus better, so we got really good pictures in there. And as we went further to the bottom, and where you see we're missing stuff over to the bottom right, there was a lot less texture, a lot less things going on in the pictures, and so they tended to be blurry. And that's why they didn't process into when we put them into Pix4D for this. So it's one of the things that we're going to keep playing with. That, I mean, if we could put lights on a drone and have the drone light itself and go through a scene, that's got amazing potential, especially for like search and rescue sort of applications. But just to show you that it is possible, and kind of what the 3 different scenarios look like.
Awesome. Drew, I really appreciated that commentary, and I think showing folks that these maps are possible to be made with the drone, you know, either having scene lights, headlights, or having lights on the drone itself are important. But I think what's clear out of here is that having specific scene lights is going to make this job a lot easier. A couple things I want people to keep in mind is that photogrammetry can only reconstruct what you can see in your image content. That basically means that for photogrammetry, for the Pix4D software to take all these images that your drone collected in its autonomous grid mission, where it's taking a ton of overlap, like Drew said, which means that each photo that the drone captures, it shares 70% of its image content with the photo in front of it, with the photo next to it, with the photo to the left and right of it, right? So we're taking tons and tons of photos of the scene, and then Pix4D software is extracting information from all these photos and making the 3D model and the two-dimensional map. And essentially, you have to turn what is a completely dark scene into a daytime scene so that the camera on the drone can absorb enough light and be able to clearly see what's on the ground. And one problem with just using headlights or just using, lights that have been bought off the shelf, that they're not LEDs, they don't have a forward directional capacity. The light changes illuminance as it changes over distance and over time. Basically, what these terms mean is, yes, you can use just headlights on a drone, or sorry, headlights on the vehicle. You can just go ahead and take the lights on the top of a fire truck, but you're not going to be able to see everything clearly. The light's going to interfere with the light coming off different sources, and it's going to cause tons of these shadows. So it's totally possible. You can absolutely do it, but it's not going to be as good as if you had specific crime scene lights like Foxfury makes, which quite frankly are the best on the market, which is why we're chatting with Antonio here, is because their lights have constant illuminance. They're LEDs that over a large, distance, they have the same amount of power, you could say. I think that's a really easy way to explain it. And also, because it's the same exact light on all the different lights, right? It's the same LEDs on, if you have 4 lights out there that are on the 4 corners of the scene, all looking inside, you're not going to have what we call destructive interference, where essentially the wavelengths of light are interfering with each other to make the shadows look worse or to change the color on the ground. You want to make, one of the reasons that I'm really hype on the Foxfury lights is because it's the same amount of illuminance that's coming out of all of them. So you're not having any color corrections on the ground. Stuff's going to appear as it really would to your human eye. And sometimes different lighting sources where the light color is different, it changes the color of items on the ground so that in the photos they look different than they would to your human eye. And I think that's the really important thing here, is that the reason we're kind of being proponents of these fancy lights is because you want to turn the whole scene that's at night into what it would look like during the day, and you want to make sure that the colors are the same so that everything looks as it should and lies where it should. And you can clearly see that in these examples of these ortho mosaics or these 2D maps that Drew has, where on the left side with the headlights, you can see that on the edges, it appears as if everything's red, right? And that's clearly coming from the lights of the emergency vehicles and some of the street lights that are out there. Whereas if we look at the scene directly on the very rightmost map where the Rugos were used, where you have that drone light itself, it looks as if it was almost during the day, and it looks like, hey, you can see things clearly and the colors appear as the colors should in the daytime. And I think that's the real key component of why setting up lights is super important. And then Drew, when you're flying these missions, I think it would be good to tell folks kind of what's the overlap you use, what's the altitude that, or maybe we go into that during the Q&A. But I wanted to tell folks what the exact workflow you're using is as you do this stuff.
Yeah, and I don't mind showing it on here. Only other thing I was going to talk about while we're still talking about lighting stuff with this slide is if you look at the Rugo one, one of the things I really like about this and I want to keep testing and try and figure out is if you look in the ditch where the body is, I mean, that's not by accident. We threw it in a ditch on purpose because we wanted to see what the shadows would be in this grassy area. The first, the headlights and the Nomad, I mean, there's going to be shadows in there, but by putting the lights on the drone itself, I mean, it really lightens up the area and you're able to see a lot of that. So there's trade-offs. We're trying to figure some of that out. I'll tell you that all 3 of these, well, the first 2 were flown at 75 feet. Most of our scenes are flown higher than that just because we have a lot of trees in Fort Collins and we've got to be sure we clear them. But for testing, we did 75 for both of these. We do everything. All of our image capture is done with the Pix4D capture app that we've tried, other software, DJI, you name it. And this one's just the easiest for me. It's super fast. I can open it up on my tablet, and we still run all of our mapping missions off iPad. All of our normal missions that we're flying, we're doing like tactical operations. A lot of times we'll throw on a crystal sky, but it's still really easy to do this on the capture app. We will put in our mapped area. Go into the advanced settings. We'll usually have, this is truly vertical, so we're looking directly 90 degrees below the aircraft to take these pictures. Overlaps, wanting to say that we're right around 80% front, back, side. And then, which is important because when we go into like where I have to take pictures out of this middle one, I have enough pictures I can take them out and still have good overlap. And then the other thing you have to know about mapping at nighttime is the aircraft has to stop every time it takes a picture. You can't have this set to where the aircraft, even if it's moving super slow, if it's continuing to move, all of your images are going to be blurred. So what's nice about the capture app is it's very easy in the advanced settings. You just put it into safe mode, which a lot of people, if you don't know what that is, it kind of freaks you out thinking that you're going to do something weird with the software. But all you're really telling it to do is to stop at every place it needs to take a picture, take the picture, and then move to the next place. But it's really important for these nighttime scenes to eliminate that blur. And then the last I was going to say about altitude, the Rugo, I flew that one at 75. I wanted to get more light than what I was getting at 75 feet. So we ended up flying that one at 60 feet. Difference of 15 feet made all the difference, and it lit up much better. And that's the only one that we had, because we're flying with the lights on the aircraft, that's the only one I had to manipulate the camera settings in the Go app. I had to keep the aperture wide open. We had to increase the shutter speed so we're sure we get enough light on that sensor to get a good picture, which again is why the aircraft has to stop for each one. Whereas the other two, what you're seeing is that was just automatic camera parameters. We let the camera decide what it wanted to do for pictures.
Awesome. Hey, thanks so much, guys. I've got 3 questions that pertain to this slide, and then we'll move on to the rest of the questions here in a moment. We'll start with the first one. On good, we've got a question here. How does light, color, temperature impact the Pix4D mapper processing?
This is a great question. So Pix4D will process what you give it in the images. That's why earlier I said photogrammetry will only reconstruct what you can see in the image content. Pix4D does a little bit of color correction on the actual orthomosaic production in step 3 of Pix4D Mapper on the desktop, but quite frankly, it's very limited. And we really try to make sure that the colors and exactly what you're seeing in the photographs is what's being reconstructed with the photogrammetry for the point cloud on the ground itself. And that's really important to keep in mind. And that's why the workflow in the field for the nighttime stuff is super important. That's why safe mode, like Drew just said, is super important, where the drone stops, takes its photo, goes to the next point, stops, and takes its photo. That allows the camera to kind of reset, absorb exactly what it's seeing, absorb all of the ambient light that's been available from your lighting systems, etc., and be able to really take into account exactly what's on the ground. And that's why the lights come into important, because Pix4D is not going to do a lot of color corrections. And I don't think there's very few people out there that are going to edit your photos after you capture them before you put them in Pix4D. That's really complicated. Like, only folks in the film industry do that. So for this use case, it's really important you set your lights up properly, which is why we're out here talking about lights.
Thanks, Angud. And a follow-up to that from the same gentleman, he noticed that the Rugo ortho had less contrast for the grass color. Does Pix4D have any kind of difficulty stitching with less contrast in a photo?
That's going to affect photogrammetry overall, where very homogeneous scenes, like if you try to reconstruct a white wall, it's not going to look very good. But if you put a bunch of sticky notes on the white wall, you have more texture, you have more stuff happening, and so it'll reconstruct. But I think when we talk about this isn't going to really affect collision reconstruction. This isn't going to be something, that affects this particular use case, because there is going to be enough differentiation in the color of the grass, and there is going to be enough texture, because we're calculating hundreds of thousands of these points in the software. So realistically, in the real world today, with the advancements of the software, I think scenes that were harder to reconstruct 4 or 5 years ago because it was homogeneous and maybe a lot of the same color on the ground, today that's not really an issue, because the software has gotten better, the cameras have gotten better, and we've figured out the workflows as much. So I wouldn't worry too much about that.
And
Awesome.
I would also add into that, for that one you're seeing with the Rugo, is that it does get a lot more homogeneous where that grass is, because the the sensor or the camera was not focusing the way we would want it to be. It was having a harder time focusing. So because it was already a blurred image, it all appears to be about the same color.
Awesome. And one last question for Drew here before we move on. Someone was asking, would it be kind of the ultimate solution to do a test with the Rugos and the Nomad in combination? Is that something that may work, or would washout occur?
No, I think that that's a great idea, and that'll be one of the things that we try out for sure. This was all done. You can kind of tell we all did this in one night. So when our 4 hours was up, we kind of called it a night. But as we get more scenes and as we're trying these on actual collision scenes, I think that that's going to make a lot of sense for us to have lighting on the drone. Because I mean, if you think about it, this scene has no trees. It has no other shadows that we're casting light from above onto our scene. And so that's going to create some issues for us. So there's going to be a necessity to have some sort of lighting on the ground in addition to what would be on the drone itself.
Awesome. Thank you so much, Drew. What we're going to go into now is just some different questions that we've had submitted and some things that we think we need to tackle for your benefit. One of the questions that was asked is, if you're shooting at night, isn't there a need for a nighttime waiver? And what are the different ways of getting approval for flying at night?
Yeah, I think the FAA has made this a lot easier for us, and it continues to get better. But you're going to have some sort of permission. That most agencies are flying under Part 107, so you're going to need to have a daytime waiver. Go onto the FAA drone zone site. You'll have the ability to apply for it. There's several places that are offering wording. You can actually phone a friend, and they'll give you some of the help with filling that out. But that's the first way to do it, is get your waiver. That way you're good in pretty much all Class G airspace to be flying at nighttime. Other option I see folks use a lot is written into their COA, that especially if you get a public safety, COA, you're going to have that already written into it, but you're going to have some sort of permission to do it.
Awesome. Thank you, Drew. Maybe a question here for Antonio. How many lights do I need for certain scenes? 1 car, 2 car? Is it based on area of ground? What's your ideal setup?
That's a really great question. Given that there's different size of intersections and highways and things like that, I would say for a standard intersection kind of type collision, I'd recommend 4 lights in the same way that Drew showed so brilliantly in that picture. And then obviously positioning the lights is going to be really important, because that'll also dictate how the shadows and how the continuity or consistency of the light is displayed. I'd say for higher speed accident scenes, something on a freeway, higher rates of speed, I would say potentially with a large debris field, you could be looking at 6 lights, possibly, or more if it's just a massive multi-car scene where people are going off the road, etc.
Awesome. Thank you. Another question here, maybe for Ongood and Drew. What stage of darkness warrants using the ground lights?
Hey, Drew, I think yesterday you had a great answer to that, so I'll let Drew answer that.
Okay, so I mean, essentially from a practical perspective, is that for me, the ground lights are more, a lot of times we bring them out when it's a scene that we need to, as investigators, see what's on the ground, right? If it's dark enough that I need to bring in light so that I can see what I need to process on the ground, that's for sure going to be dark enough that we're going to need to have lights out to fly with the drone. The thing I would say is, if you're in that period of twilight before we've gotten into dark, and you're flying where there's still a little bit of sunlight but the sun has set, you may or may not need ground lighting depending on how much shadowing you're getting, but you are for sure going to need to probably put your aircraft into that safe mode so that it is still stopping and taking those pictures, even if you're not using the ground lighting. But whenever you start seeing shadows in the ground, or for you as an investigator, if you need to see what's going on, then for sure, I mean, that's going to be your cue for bringing out ground lights.
Yeah,
awesome.
I like to tell folks it's just like driving a car, right? 30 minutes before and 30 minutes after sunset and sunrise. If you need headlights on a car, maybe you need some lights out there to collect your scene. Were there any last tips that maybe you had from practically going ahead and doing this in the field? I mean, I think we've covered a lot of the basics. It really comes down to flying low, stopping the drone at every single place it takes a photo so the camera can absorb as much light. setting up your lights properly, making sure that you're choosing good lights. And then also, do you want to do this? Do you not want to do this based on how the development of your drone program is going? Because you're right, we don't want something going bad and at night where, you know, the vision systems on the drone aren't going to work as well. And so you have to be more confident as a pilot. There are definitely things that make the nighttime more difficult, and it is very exciting because of that. And hopefully, you know, in the near future, this becomes a very standard practice out there in law enforcement. But I guess, Drew, do you have anything, you know, final last words for folks out there?
A couple last points I would just give is that, you know, don't fly super high if you're going to fly at nighttime. You kind of said to do it low, which is really important. That you know, your light's only going to go so far, and your sensor, as you start looking at the ground, you're starting to get bigger and bigger pixels as you get up higher. So we typically don't fly nighttime. My agency, we don't fly any higher than about 120 feet if we can avoid it, but certainly probably no more than 150. If we can get it down to lower, I mean, I love to fly about 80 feet is my happy spot. That's what we'll try to do. You mentioned a little bit about sensors and stuff. Just be sure that you're aware that a lot of your sensors, especially any of your sensors that are relying on a picture or being able to see something on the ground, are going to be affected at nighttime. So you can potentially get some different errors. You can potentially lose the vision of the aircraft to know where it's at, that vision positioning. And so just be aware that as a pilot, you're going to have to be brain on. You're going to have to be able to fly it when it's not in autonomous mode. Once it goes into autonomous mode and it's doing its thing, you know, it's more of a monitoring. But when you're taking off and landing, it's going to be on you. So just be aware you have fewer safeguards. And then the last thing, I guess, the last thing I'd say is it's going to take practice to do this at night. So go out, practice with it, try it a few times so you're comfortable when you get to your very first scene and all the bosses are standing there staring at you because they want to see magic. Be prepared that you already know kind of what's going to happen with your aircraft. And before you leave a scene, please, please, please find a way to look at your pictures and make sure that they're not all blurred, so that if you need to go shoot it again, you can. So you're sure you're walking back with good images. Because like Ongun's saying, if you don't have good images to put into the software can't save you. You're going to have to have good images to put in there.
You know, we're running out of time. We've definitely got some more questions, and you know, we're going to do our best to make sure everybody gets emailed that put in questions with answers. One last thing before we go, we worked with all of these guys here at FLYMOTION to get a mapping kit put together. You know, it has everything we've talked about here today, the Phantom 4 RTK, the Nomad lights, all the way down to micro SD cards that you need. We really want teams out there in the field to be well prepared and to, you know, have everything they need when they get on scene to go out and complete a night mapping mission. So we have some different levels of these. This is kind of our end-all be-all kit, like we talked about today, our best case scenario in the field. And I really appreciate Ongood and Antonio and Drew coming on here and helping us work this out and come up with the best case scenario. One thing we do want to offer for those who are on the webinar today is Pix4D is going to give everybody a free trial for Mapper or React. I will be sending that email out to those folks on this webinar. This is my email here. If you have any questions that you didn't get a chance to ask or think of anything after, please shoot me an email and I'll get you in touch with Drew or Ongood or Antonio, and we'll really make sure you guys have what you need. I hope you all enjoyed this webinar, and guys, thank you so much for joining us on here, the panelists. We couldn't have had better minds here to go through this. So I thank you all. Drew, Ongood, and Antonio, want to say your goodbyes, and then we'll sign off. Thank you guys so much for joining today.
Nope, that's great, Justin. Thanks, everyone. I really appreciate your time.
Yeah, I really appreciate everybody's time. Feel free to send me an email, ongood.sing@pix4d.com, or reach out to Justin and he can forward it to me. Here to answer all your questions. Thank you.
Yeah, and thank you everyone as well. Thanks for all that you're doing out there. Stay safe.
Thank you all. Have a great day.